जी 50
कितना फोन इससे कनेक्ट है क्या? अच्छा हेलो
Good afternoon, sir.
हेलो हाँ गुड आफ्टरनून
Good afternoon, sir.
Good
afternoon, sir.
Sir, good afternoon.
Good afternoon, sir. Screen is visible?
Yes, sir.
Yes, sir. Yes, sir, definitely.
So we have already done this binomial distribution.
Yes, sir.
Am I right? This one, this exercise we have done,
Yes, sir.
and Poisson distribution also. No, we have done Poisson also. Let me just repeat that Poisson distribution is also a discrete probability distribution, like binomial. But the situation in which Poisson distribution is used a bit different from the scenario where binomial distribution is used. So, for example, a few things are common to both Poisson as well as binomial, that both are discrete distributions, and in both cases, the number of trials, one after another, they are statistically independent. Means what has happened in the previous trial does not influence the occurrence of the events in next trial, and so on. But what is different is that there, in case of binomial, there are only two possible outcomes. Here, the outcomes are seen with reference to a given interval of time or space, as we discussed that, for example, in case of time, if you want to know, if you can see this on an average 4 persons per half an hour arrive at a vaccination center, what is the probability that there will be 6 persons arriving during 12 noon to 12:30 p.m. So we are interested in about the probability of say 6 persons arriving during this half hour period from 12 to 12:30, and historically the average arrival has been given as 4 persons per half an hour. Now this probability you can write like this: x is 6 if you look at this formula, and lambda is 4. Then using the formula we can calculate that there is only 10%, 10.4% probability that there will be 6 persons arriving from 12 to 12. Now the only variation in this type of, the value of lambda may be that if lambda, the unit of lambda and the unit of the probability that you want to know, if the two are different, then we can accordingly find out this lambda. Say for example 8 persons per hour. This has been the average arrival, 8 persons per hour, and you wanted to know probability of 6 persons arriving for half an hour. So what you will have to do, you will change this lambda from 8 per hour to 4 per half an hour. So accordingly then we can make use of either this formula or the table. This I suppose we have discussed. Here it was our lambda value, and 6 we can find out from here. So it was 0.1042. And if it is like, for example, not exactly 4 persons or 6 persons arriving, it may be at least 6 persons arriving, or it may be at the most 6 persons arriving. So as we have done in case of binomial, this principle will apply there also. Because as you know, at least, say if I am coming to this, that on an average 4 persons per half an hour arrive at a vaccination center, what is the probability that there will be at least 6 persons arriving? So how will you do that then? What will be the value of x? here, if the question is,
Sir, x greater than or equals to 6.
what is the probability there will be at least 6% arriving? Means at least 6 means 6 or more. So in that case, what will we write here?
X greater than equals to 6.
Greater than equal to 6. So it will be both. And then how will you find out from the table?
So there can be infinite people. So what we do, we will calculate the values of x less than or equal to 6, x less than 6, and then we will minus 1 minus.
Right. So that will be 1 minus probability of x. Yes, what?
Less than 6.
Less
Less
than
than 6. Less than 6.
Less than. So now it will be easy. Less than 6 means x equals 0 plus 1 plus 2 plus 3 plus 4 up to 5. So you can see from here lambda will remain this 4 and then x value you can see 0.0185 or 83. Okay, plus 0.0733 plus 0.1465 plus 0.1954 plus 0.1954 up to 0.1562. You add them all, so and subtract it from 1. So that will become your this probability. And similarly, if it is at the most 6, then it means simply at the most 6 means
so less 6 or less than 6.
at the most 6 means 6 or
Less than 6.
less. So means 0, probability at x 0 plus 1 plus 2 plus 3 up to 6.
6.
Up to 6. So that will be your answer. Now we are coming to normal distribution. Normal distribution is used for the variables which are continuous in nature. And as we know that by continuous we mean that there is no break when we measure, when we move from one value to another value, there is no jump required. Say when we say tossing a coin head or tail, so there is nothing in between. Or when we say pass or fail, there is nothing in between. When we say qualification like high school or plus 2 or graduate or undergraduate or PhD like that, so they are all qualitative type or discrete type of variable. But if you talk about, for example, marks, which you, I mean, the marks which you, the score which you receive, which you obtain after your examination, so it varies from 0 to 100 if it is of 100 marks, and if an x represents the scores obtained, then x can assume any value from 0 to 100. Means even in fraction. So in that case, it becomes a continuous variable. So the characteristics of a normal distribution are like this. It is symmetrical about its mean and it is bell-shaped. You can see it is bell-shaped and it is symmetrical about its mean. Mean is mu, it is symmetrical, and then the standard deviation is lambda, sigma. And so the area under this curve measures the probability of x being between, say, if we are trying to find out probability of x ranging from this value to this value, then this whole area, the green area, will be your probability. If we say this is the mathematical formula to find out the probability in case of normal, as we have seen the mathematical, yes, for Poisson as well as we have for binomial. This one, similarly, we have probability distribution factor, what is called function PDF. So normal distribution values are calculated using this one, where you can see x is the variable, mu is its mean, and sigma is standard deviation. But again, rather than using this formula every time, we can make use of this normal distribution table. But as we know that if you change either of the two, a normal distribution is described by two parameters. One is its mean, the other one is standard deviation. Say in an MBA group, the average marks and standard deviation, there is one pair. For another group of MBA, say MBA IB, the mean and standard deviation, this is another pair. We can have the third pair of mean and standard deviation for the MBA IBF, and fourth pair of mu and standard deviation for MBA HA. So we cannot have four different tables, because in this case we have four. This could be any number of such combination of mu and sigma. So therefore what we do to avoid that complication, we can convert that pair of mu and sigma into a standard normal distribution, what we call as standardized normal distribution, or Z curve. And how do we convert that? We make use of this formula here, this one. Z equals x minus mu over sigma. So what we do, on x-axis we have x variable, and on y-axis we have frequency. When we convert this x into z, then a standard normal distribution is obtained, where on the x-axis we have z values rather than x values. Now look at this example. A certain type of battery lasts an average 3 years with a standard deviation of 6 months. Means there is a battery manufacturing firm which manufactures batteries. For example, car batteries or inverter batteries or any other battery for your cell phone, battery of your laptop. So there is a certain company which manufactures batteries, and those batteries historically the life of these batteries has been on an average 3 years with a standard deviation of 6 months. Means in some cases it was 3 years plus, in some cases 3 years minus, up to 6 months on each side. Assuming that the battery lives are normally distributed, find the probability that a randomly chosen battery will last for less than 2.3 years. So that means if the company that manufactures batteries is manufacturing for each cycle, say 100 batteries, and the average life of those 100 batteries comes out to be 3 years with a standard deviation of 6 months, because you know whatever good or accurate process may be, the dimension or the parameter, it may not be exactly the same for all units being manufactured. If the company is producing 100 batteries per day, for example, so although the machines are same, people are same, material is same, even then all batteries, all 100 may not have exactly the same life. So if we take average through testing, we find that average life was 3 years with a standard deviation of 6 months. Now what we do, we randomly choose one battery out of that 100, the lot of 100. And we wanted to know what is the probability that that battery will last for less than 2.3 years. So what we do, this is your normal curve for this battery, and this value here is in this is 3 years. The middle point is, this is your mean value, which is 3 years, and on this side we have 3 plus, and on this side we have 3 minus. theoretically, this end is minus infinity and this end is plus infinity. But as you can see from here, theoretically it is minus infinity to plus infinity, but we consider this plus minus 3 sigma limits on both sides, then this total area under minus 3 sigma to plus 3 sigma covers almost 99.7% of this area. Still 0.37% is remaining because of that theoretical concept that the two ends of normal distribution are not meeting the x-axis, but they are open, and they are open till infinity on each side. Anyway, so that is the theoretical part. Now, this is your average 3 years. It may be now here 3.1, 3.2, 3.3 and so on. And on this side 2.9, 2.8, 2.7 and so on. So if you wanted to know what is the probability that the randomly chosen battery will last for less than 2.3 years, then less than 2.3 years is this area. Am I right? This left tail which you can see the shaded portion. Correct? Any question?
Sir, you said that the range of this graph is from minus 3 sigma to plus 3 sigma, and the sigma here is 0.5. So the range would be from minus 1.5 to plus
Means
1.5.
yes, 3 plus 3 times 0.5 means 1.5. So
Yes, sir,
maximum
minus.
4.5.
So we have, so the 3 years will be in between the minus 1.5 to plus
You can
1.5.
yes, you can see the this point. You can see my cursor.
Yes, sir.
This one. So this is your 3 years, and then from here 3 plus sigma, 1 sigma, 2 sigma, 3 sigma up to here. So 3 sigma means 3 into 0.5,
1.5.
1. So its maximum limit, practical limit is 4.5 years. आपने
Okay.
देखा भी होगा जो इन्वर्टर की बैटरी सभी के घर में होती है, उसकी एक लाइफ होती है 24 मंथ्स या 30 मंथ्स, लेकिन कुछ कुछ बैटरी उसके बाद भी दे रिमेन ऑपरेशनल. एम आई राइट?
Yes, sir.
आपने सबने एक्सपीरियंस किया होगा, चाहे वो कार की बैटरी पे या अपने घर में इन्वर्टर की बैटरी पे, कि एक उस पे मेंशन होता है कि 24 मंथ्स वारंटी है, या बेसिकली दैट वारंटी इज इट्स लाइफ, या 36 मंथ्स वारंटी है, या 30 मंथ्स वारंटी है. 30 मंथ्स मींस 2.5 इयर्स. लेकिन ऐसा नहीं है कि ठीक 2.5 इयर्स में वो बैटरी जो है वो एक्सपायर हो जाएगी. कभी वो उससे पहले भी हो सकती है, कभी उसके बाद भी हो सकती है. वो वेरिएशन सिर्फ इसीलिए है कि इंडिविजुअल बैटरीज की लाइफ मेजर नहीं की गई. So in this case, with this example, maximum life maybe it's 4.5 years and minimum life maybe
1.5 years.
how much? 1.5 years.
1.5.
और theoretically अगर देखें तो I mean of course इस बैटरी के केस में माइनस इन्फिनिटी तो नहीं हो सकता, जीरो कह सकते हैं. आप पहले दिन बैटरी लाए उसी दिन वो फेल हो गई. That is possible. अब वो चाहे उसकी जो सेल प्लेट्स होती हैं वो डैमेज थी, या उसका एसिड डाइल्यूटेड था, इट वाज नॉट कंसंट्रेटेड इनफ, या कोई और उसमें मैन्युफैक्चरिंग डिफेक्ट था कि आप बैटरी लाए और बैटरी आपने यूज़ की और बैटरी ने वर्क नहीं किया. दैट मे बी द मिनिमम पीरियड मीन्स 0 ईयर्स. और मैक्सिमम आप देखते ही हैं कि वो एवरेज के बाद भी बैटरीज आपकी वर्किंग में होती हैं. And then whatever period is there, so that is theoretical. Minus plus infinity नहीं हो सकता कहीं न कहीं, चाहे वो 4.5 years हो, 5 हो, 5.5 हो, the battery will stop functioning. So that was only theoretical concept, minus infinity to plus infinity. Anyway, so here we have the midpoint, the average 3 years, and like this. So where will this 2.3 be marked? Because it is less than 2.3 years. So for example, this is the x value of 3 point, this one here. This one is your 2.3, and less than 2.3 means this shaded area. So this distribution, normal distribution table, if you look at this, the values are all for positive values, means from 0 to z value on this side only. Say for example, if your z comes out to be 1.5, it means the area from 0 z equals 0 to z equals 1.5, and 1.5 z you can locate here. This value will be 0.4392. 0.4392. So that will be your from 0 to z equal 1.5. And if you are interested in finding out the same value on the negative side, then value will remain same because this graph is symmetrical about its mean. So here also in this case, when you convert x into z, so z equal 2.3 minus mu is 3 divided by 0.5, it comes out to be minus 1.4. तो मीनिंग ये हुआ कि ये जो 2 पॉइंट इस पॉइंट पे 2.3 जो था x की वैल्यू, वो z की corresponding वैल्यू comes out to be minus 1.4. Are you getting this point? 2.3 years as x value is converted into z value, which comes out to be minus 1.4. Therefore, probability that x is less than 2.3 may be written as probability of z less than minus 1.4. And now if you look at this value 1.4 z, so z 1.4, you can see here 1.4 is this, and what is its value? Can you read from the screen? You have table at z equal 1.4, 1.40 I should say, because this column is for 0, second decimal place, 1.40. How much is? Can you read it?
Sir, it's not clear.
What is the probability here for
Not visible.
z equal 1.4?
So it's blurred actually, so we cannot see it.
Anything you can find. Okay. And you also don't have table with you. Asking that you should have these 3 tables with you for these classes. Anyway, so this is the value which is 0.4192. Can you see the cursor?
Yes, sir.
At least location you should know, this location. 1.4 and under 0 here, 1.40, it is 0.4192. So 0.4192 is this area. From 0 to z equal 1.4. And same is here. Although we are interested in the negative side, but the value which we obtain from the table is always for positive side. But it is symmetrical. So 0.4192 is this area between 0 and 1.4. Between 0 and 1.4. So this area here is 0.4192. 0.4192 is this area, and we are interested in this. How much is this mean to this end? How much is this area? Anyone who can guess?
Sir, 1.5.
Half of
means
half of this. Total area from here to here is 100%. This total area under the curve is 100%. 50% on the left hand side, 50% on the right hand side. So this total area is 0.5. Similarly, this total area is 0.5. So this is 0.4192. How much will this be?
0.5 minus 0.4192.
0.5 minus 0.4192 will be this area. and it comes out to be 0.0808. Means if you randomly select a battery from the lot and you wanted to know what is the probability that this battery will have a life of less than 2.3 years, so the probability of this is 8%, 8.08%, that a randomly chosen battery will last for less than 2.3 years. Any question up to this?
No, sir.
Sir, I have a question in the previous topic.
Yes. Previous problem means poison.
Yes, sir. Can you just move the
Yes.
so one more page up? Yes, sir. So here you told us that we have to change the unit of
Uh,
lambda according to x.
mm-hmm.
So why can't we change the unit of x according to lambda?
No, because you see that lambda is a historical value, means the past, on the past experience or the past data, the system has found that on an average 4 persons arrive per half an hour. But you are interested in something going 6% for half an hour. जैसे आप ऐसे समझिए कि इसको प्रैक्टिकली समझने की कोशिश करें कि हमारे पास कोई विंडो है, बैंक समझ लीजिए, फॉर एग्जांपल बैंक है, बैंक ओपन्स एट से 10 o'clock एंड वर्क्स टिल 4 PM। अब हमारे पास स्टाफ की कमी है और हम ये देखना चाहते हैं कि किस पीरियड में सबसे ज़्यादा रश होता है, उसमें हम स्टाफ ज़्यादा रखें और जो लीन पीरियड है उसमें हम कम रखें। Now we divide 10 to 12, 12 to 2 and 2 to 4. Now we wanted to know, for example, कि what is the probability कि 12 और 2 के बीच में 100 कस्टमर्स आएंगे। तो वो probability आपको 12 से 2 के बीच में चाहिए। तो आप इस 2 आवर्स, इस 2 आवर्स टाइम को नहीं चेंज करेंगे और आपको लैम्डा, आपको ये पता है कि पूरे दिन में हमारे पास ऑन एन एवरेज, ठीक है ना, on an average means for how many hours we are talking about?
2 hours.
Half an hour.
Hmm?
2 hours
6
according
ना,
to the bank.
10 to 4. So हमारा
4
जो
hours.
एवरेज है वो हमको मालूम है कि साहब 200 लोग रोजाना आते हैं बैंक में। तो जो जो एवरेज हमको पता है वो एक लॉन्गर इंटरवल के लिए पता होता है और हम इंटरेस्टेड हैं किसी और पीरियड में कुछ नंबर ऑफ अराइवल्स को जानने के लिए। तो इसलिए हम उस लैम्डा को अपने हिसाब से कन्वर्ट करेंगे, ना कि जो हमारा क्वेश्चन है, जो हमारी प्रॉब्लम है, उसको नहीं कन्वर्ट करेंगे लैम्डा के हिसाब से, क्योंकि लैम्डा इज फॉर द एंटायर डे, 6 hours डे फॉर एग्जाम्पल। या आप वीक में बात करें कि ऑन एन एवरेज पर वीक मीन्स से 5 वर्किंग डेज, तो ऑन एन एवरेज 5 दिन में कितने लोग आते हैं। अब आपको ये पता करना है कि मंडे में हमारे पास इतने लोग आएंगे कि नहीं आएंगे। तो मंडे मीन्स एक दिन की बात हुई। तो अब हम उस जो एवरेज हमारा 5 डे का है उसको 5 से डिवाइड करके एक दिन का एवरेज हम कैलकुलेट करेंगे, तब उससे प्रोबेबिलिटी निकालेंगे कि मंडे में हमारे पास व्हाट इज द प्रोबेबिलिटी कि देयर विल बी फॉर एग्जांपल 100 customers or less, 100 customers or more and so on. Is your question answered?
यस सर। तो मतलब जो पहले से गिवन है उसको हम चेंज करना है, जो हम पूछ रहे हैं उसको नहीं करना है, उसके हिसाब से
जाहिर
चेंज करना है।
you see, you can't change your problem, the decision that you want to make, the factor, but what you can modify, चेंज नहीं कर रहे हैं, उसको कन्वर्ट कर रहे हैं, चेंज नहीं कर रहे हैं, कन्वर्ट कर रहे हैं। हमारे पास डाटा है एक दिन का, तो हम अगर उसको आधे दिन में जानना चाहते हैं तो व्हाट विल वी डू, हम उल्टा नहीं करेंगे ना कि हम पूरे दिन का पहले कैलकुलेट करें फिर हम आगे डिसीजन कैसे लेंगे। जैसे मैंने आपसे कहा कि मुझको तो ये देखना है कि 12 और 2 के बीच में मैक्सिमम रश होता है कि नहीं होता है, तो मैं अननेसेसरी 6 घंटे का क्यों निकालूंगा, मुझे तो 12 से 2 के बीच में चाहिए, क्योंकि मुझे उसके आगे उस पर डिसाइड करना है कि हाउ मेनी एम्प्लॉयज शुड वी हैव ड्यूरिंग 12 to 2, वो जानने के लिए। और जो मेरे पास एवरेज है वो एवरेज पर डे का है, तो आई विल मॉडिफाई द एवरेज रादर देन व्हाट आई वांट टू नो। So now look at this second problem. A placement company has conducted a written test to recruit people in software companies. Assume that the test scores are normally distributed with mean as 120 and standard deviation as 50. Determine the probability that a randomly selected score is greater than 200. For example, this test was conducted for, say, 250 marks. Maximum marks were 250, and there were 1,000 candidates who appeared for this placement test. So there will be, I mean, individuals may have their scores differently, but if you take average of 1,000 scores, that comes out to be 120. अब उसमें कुछ लोगों का 250 में से 120 भी आया होगा, कुछ लोगों का 110 आया होगा, कुछ का 200 आया होगा, कुछ का 225 आया होगा, 230 आया होगा, 198 आया होगा. All values are possible from 0 to 250 if 250 is the maximum marks. उन सब 1000 candidates का average comes out to be 120 with a standard deviation of 50. अब उस 1000 में से if we choose 1%, what is the probability कि उसका score 200 से ज़्यादा था? What is, if you determine the probability that randomly selected score is greater than 200. So now you look at this again. This is your diagram. The midpoint is 120 and 100 and अच्छा इसमें हम second part का show किया है 180 or less. Anyway, both are shown here. If it is greater than 200, where will you have 200? On right hand side or left hand side of 120?
The right hand side of 120.
Right hand side, say instead of, it is for example 200. So greater than 200 means we are interested in this area. Okay? Greater than 200 means this right tail of this diagram. But the value which we will obtain from the Z table will be this area. Because again, if you look at this, it always reads values from 0 to Z value on the right hand side. So therefore, whatever Z comes out to be, so the table will read value from this point to this point. And then what will you do again? From this whole area, 0.5, you will subtract this area to get this probability. अब देखिए x minus mu over sigma, it comes out to be 1.6. X is what? What is x here?
Mean
100.
120.
नहीं, x is 200.
200.
First part.
200.
Mu is 120 and sigma is 50. So z comes out to be 1.6. So probability that x is greater than 200 can be rewritten as probability of z greater than 1.6. तो z की वैल्यू 1.6 पर हम फिर पढ़ेंगे. 1.6 पर इसकी वैल्यू आती है 0.47, 0.4452. So this area is 0.4452. Now from this whole area, which is 0.5 minus 0.4452 will give you this right 0.0548, means the probability is 5.5% chances that a randomly selected candidate has obtained more than 200.
Sir,
Second part,
sir, I think this value of Z 1.6 is for the x equals to 180.
अच्छा चेक कर लीजिए अगर
Yes, sir.
180
I have checked it. It's yes, sir.
if it is for 180 then make it 180. So 180 or less. 180 or less means ये देखिए पूरा यहाँ से जो you can see the line. This whole area is 180 or less. 180 or less. Less means up to where? Up to this point. तो अगर ये 1.6 इसके लिए है, then this calculation is wrong because what you have obtained is for, are you sure 1.6 is for
Sir,
180? Let
I
me,
don't get it. How is it for 180?
So 180 minus.
let
Sir, I
me,
think it's for 200.
चलिए let me also check, मुझे कैलकुलेट करने दीजिए, आप लोग भी ये x की वैल्यू रख के देखिए ना उसमें भाई, इसमें इतना कंफ्यूजन की क्या बात है, कैलकुलेट करते हैं अभी। अगर ये 200 है, 200
Yes,
माइनस
sir. It's for 200, sir. Sorry, sir. I was thinking it's 100. It's for
डिवाइडेड
200, sir.
हाँ, इट इज फॉर 200,
Yes, sir.
ठीक है, चलिए इट इज फॉर 200, it is for 200, done. So in that case it will be 0.5 minus 0.4452 for 5.48%. Now if it is the case for 180 or less, so 180 or less means this area, ये छोटा वाला, ये up to ये पूरा area, this whole area is 180 or less. यहाँ भी आपको अब 180 के लिए कैलकुलेट करना पड़ेगा, व्हाट इज द z वैल्यू फॉर 180?
1.2.
1.2, sir.
1.2, तो 1.2 पर if you look at 1.2, 1
So 0.3849.
0.3849.
1 point
So
0
1
point
3849.
So 0.3849.
3849, okay,
Yes,
so
sir.
that means 0.3849 will be this area, and what will you do to get this complete area?
0.5 plus
You
0.3849.
5 here, so that will be your answer, 88% or something.
Yes, sir.
So the 88% is the chance that a randomly selected score will be 180 or less. So this is how we make use of this Z table. कभी आपको 0.5 में से घटाना होगा, कभी 0.5 में ऐड करना होगा. So whenever you have a problem to be solved for normal distribution, it is always advisable first draw this normal curve and shade the required area. Then it will be easy for you to find out these values. Done? Okay, now after this class, I and Dr. Asif will discuss that we will be sending you a sheet of 4 or 5 questions based on what we have done till now. So that will be your assignment, which you need to submit within the given period, जो भी उसमें mention होगा. So that question sheet will be uploaded on either your some Google Classroom or maybe on your WhatsApp group. So today we will finalize and we will send you the assignment sheet. It will consist of 5 questions. You will be solving it in writing, handwriting, and then you submit your answer sheet by the last date, whichever will be mentioned on that, and then we will have a quiz also through Google form. There will be a set of say 10 questions or so. Of course, objective type, you will solve and take the correct answer, whatever you think is correct, and then submit it. So this will be your assessment, internal assessment part, and then when you come for the final exam, means end semester exam out of 30, that there also we may discuss your answers, your answer sheet, means the assignment as well as the quiz, because instead of having a separate viva, at the time of final viva, we may also ask you questions related with your assignment as well as quiz. So this is how we will be conducting this assessment, internal assessment out of 70, which will consist of these two things: one numerical sheet of 5 questions, which we will be solving and submitting in handwriting, and one quiz of say 10 questions or so. Let us decide. And that quiz plus this assignment plus your response in your exam. So some of the weightage, because there we will be assessing that who has done this this assignment and which one is genuine, which is not genuine. So to understand that, and then only we will finalize your out of 70 and plus on the spot out of 30 for your final exam. This is how this will make 100. Now the remaining portion that we have is there are two things. One is related with project management or network techniques, and the other one, fifth unit, which consists of different topics which are from operation research area. So generally what we do that we brief, we engage a session to brief you about those 4-5 techniques, and then we provide some material on those techniques, because generally we do not go for the numerical part from that fifth unit. So because it consists of various different topics, we give just the conceptual part, that what does that technique mean and what is its application. Generally, we do not ask numerical questions from that fifth unit as far as this online mode is concerned. So therefore, we will be devoting one session or two sessions for the fifth unit, and then sharing some material with you. So that will be fifth unit. But this fourth unit, project network technique, we will start from tomorrow, and this is on CPM and PERT. If you have some ideas, so CPM and PERT we will be doing tomorrow onwards. If you have any question related with your assessment or something else, I still advise that you should have some book for practice. If you have some question, please ask, then we will close the session for today. Okay then, thank you.
Thank you, sir.
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 Thank you, sir.